Paper 4, revision paper 4, part 1. In paper 4, we must know some comparisons. Number 1, the difference between atom, ion, isotopes. Number 2, difference between bonds. We have 3 types of bonding: ionic, covalent, and this covalent contains simple covalent and joint covalent and metallic. Number 3, making salts, the 3 types: neutralization, titration, and precipitation. Number 4, Haber process and contact process. Number 5, the effect of heat on hydroxide, carbonate, and nitrate. Number 6, extraction of metals from their ores. Extraction of iron, making steel. Extraction of zinc, and extraction of aluminum. This is part 1. For the first point, the difference between atom, ion, and isotopes. We said that the difference between atom, ion, and isotopes, that atom is electrically neutral. It means that number of positive charge equal number of negative charge. So proton is equal to electrons, and number of positive charge equal to the number of negative charge. Like Na, like Cl, you will find that in case of Na or Cl, that protons equal 11 and electron is equal to 11, so proton is equal to electron. While in case of ion will be difference. So also in chlorine, you will find that protons is equal to 17 and electrons is equal to 17. So atom is electrically neutral. It means that number of positive charge equal number of negative charge, and the number of protons is equal to the number of electrons. While in case of ion, ion is a charged atom. A charged atom means that atom after losing or gaining electrons. And in case of ion, you will find that protons not equal to electrons. Maybe protons is greater than electron, or electron is greater than protons. In case of proton is greater than electron, it means that this is positive ion. While in case of electron is greater than protons, this means that negative ion. Like Na positive or Cl negative. The difference, you'll find that protons is equal to 11, while electrons is equal to 10. In case of negative ion, protons equal to 17, while electrons equal to 18. Isotopes. Isotopes means that atoms of the same element. We must say same element with same atomic number and different mass number, or with same number of protons and different number of neutrons. So same atomic number or number of protons and different mass number or different number of neutrons. They are same element and they have same chemical properties. Okay, Ahmed, you can pause the recording 1 minute. And we said that isotopes have same element and they have same chemical properties. Explain why for both. Same element because they have same number of protons. And why they have same chemical properties? They have same number of electrons in the outer shell. This for the first one. And you'll find that in case of isotopes, like C612, C613, C614, you will find that protons is equal to protons, electrons is equal to electrons, while neutrons not equal to neutrons. Because all of them here, protons equal 6, electrons equal 6, neutrons 6, 7, 8. So in case of atom, proton is equal to electron, ion, proton is equal to electron, and maybe proton is greater than electron in positive ion, or electron is greater than proton in case of negative ion. While in case of isotopes, you'll find that proton is equal to protons, electron equal electron, but neutron not equal to neutrons. This is the first point. After that, for point 2, for the bonding. In bonding, we said that we have ionic, covalent, and metallic. In case of ionic, you'll find it formed between metal and non-metal. Metal by losing electrons to form positive ion, and non-metal by gaining electrons to form negative ion. So for ionic bond is a bond formed between positive and negative ion. While in case of covalent, you will find that formed between non-metal with non-metal. And it is formed by sharing of electrons. In case of metallic, it is formed between metals and then the attraction force formed between positive ion and free moving electrons. So the attraction in ionic formed between positive and negative ions. In case of covalent, the attraction formed between nucleus and outer electron. This is the attraction force. While the attraction force in metallic between positive ion and the free moving electrons. So for drawing of the LATs, you'll find that Ionic contains positive and negative ions, positive then negative, positive then negative. This is called Ionic LATs. What is meant by Ionic LATs? Regular arrangement of alternative positive and negative ions. While in case of metallic, it contains also LATs formed between positive ion and free moving electrons. So describe for each bonding, describe ionic bonding or ionic LATs, regular arrangement, these ionic LATs, and these metallic LATs. You'll find that in case of ionic LATs, regular arrangement of alternative positive and negative ions or oppositely charged ions. While in case of metallic, there's a bond formed between positive ions surrounded by sea of free moving electrons. And then for the properties of each one, you will find that properties of ionic compounds have high melting and boiling point, conduct electricity when molten or aqueous, molten or aqueous only, doesn't conduct through solid, dissolve in water. And then explain why for each one. Have high melting and boiling point due to attraction force between positive and negative ions. And conduct when molten or aqueous due to free moving ions. And we said in case of molten or aqueous, we say ions, while in case of solid, we are saying electrons, no free moving electrons. And dissolve in water because it is polar compounds. Polar, it means that it contains two poles, positive and negative. So this is the properties of ionic. For the difference between ionic and covalent, you will find that covalent, low melting and boiling, doesn't conduct anyway, doesn't dissolve. In case of metallic, you will find that high melting and boiling conduct in solid and liquid, but doesn't dissolve. So we can make a comparison for that. How can we know this solid, liquid, or a gas? This metal, or ionic, or covalent, or joint covalent, or impure water? How can we know for example? You will find that if we make a comparison, how can we know this solid, liquid, gas, metal, ionic, covalent, joint covalent or macrocovalent, impure water, or aqueous sodium chloride? And then point of comparison between melting point, boiling point, conductivity through solid, conductivity through liquid, and dissolving in water. melting point, boiling point, conductivity through solid, and liquid. Liquid means that molten or aqueous, and then dissolving in water. You will find that in case of solid, liquid, or a gas, how can we know for the states of matter that we have 25 degrees Celsius is the room temperature. So if we have higher melting and higher boiling greater than 25, so it is solid. For liquid, melting point is lower and boiling point is higher, this is liquid. For a gas, both of them will be lower than 25. For example, if I have 100 and 500, for example, this solid, 0 and 100, 25 in between, -50 and -5, for example, you will find that this solid is liquid is a gas. For the metal, high melting, high boiling, these are properties for each one. Can conduct through solid and liquid, but doesn't dissolve in water. While in case of ionic, high melting, high boiling, doesn't conduct through solid, conducts through liquid, and dissolve in water. For covalent, low melting, low boiling, doesn't conduct and doesn't dissolve. For the joint covalent like diamond, graphite, and silicon, you'll find that have high melting and boiling, but doesn't conduct and doesn't dissolve, except graphite. And then for aqueous sodium chloride or impure water, it must be lower than 0 and greater than 100 because the impurity decrease the melting and increase the boiling. Doesn't conduct through solid but conducts through liquid and dissolve because it is ionic. After that, for drawing ionic and covalent and joint covalent. Drawing ionic, how can we draw for ionic? For example, if we have Mg3 and 2 or Al2O3, you will find that we have group from the periodic tables and valency. For Mg, group 2, for N is group 5. For the valency, 2 positive, 5 is 3 negative. Then we will make Mg and then N. Number of atoms will be out, 3 and then 2. This is the number of atoms. And then for the valencies, 2 positive, 3 negative. After that, it contains 5 electrons in the outer shell, 1, 2, 3, 4, 5, and then gaining 3. 1, 2, 3. So again, for drawing ionic compounds, how can we draw? Group and valency, and then this group 2 and group 5. Group 2 valence 2 positive, group 5 valence 3 negative. How many atoms? 3 and 2. For Mg is completely filled shell. And then we have the valence is 2 positive and 3 negative. It contains 5 electrons in the outer shell and gaining 3. Another one for Al2O3 will make Al, then O. After that, the number of atoms, 2 and 3. For Al, you will find that group 3, valence is 3 positive. Group 6, valence 2 negative. So 3 positive and 2 negative. After that, it contains 6 electrons in the outer shell. 1, 2, 3, 4, 5, 6, and then gaining 2. This for drawing of ionic. For covalent, For example, if you have CH3, CH2OH, or if we have CH3, COOH, or if we have CH3 by 2S. How can we draw covalent? You will find that we are making group valencies the remaining. For carbon, group 4. For hydrogen, group 1. For oxygen, group 6. This is a group valency 4, 1, 2. No need for positive or negative in covalent. And then the remaining is the difference, 0, 0, 4. Then CH3, CH2OH, we can make it like that. C is combining with 3 H's, then C with 2 H's, then O, then H. It will be like that. C with 3 H's, after that another C with 2 H's, and then O, then H. For the sharing, for H1 sharing by 1, for HO sharing by 2, for H carbon sharing by 4. So 1 by 1. For example, if we make for the H symbol X, and for HC, we can make dot. For HO, we can make O, small. So 1 with 1 for each one. After that, remaining 1 with 1 for the carbon, and then 1 with 1 for oxygen, and another 1 with 1 for the other oxygen. So you'll find that for each H sharing by 1, for each carbon sharing by 4, 1, 2, 3, 4, 1, 2, 3, 4, and for each O sharing by 2, then we have remaining. This remaining for oxygen only, we have 4 remaining for oxygen. After that, in case of CH3, COOH, this is inorganic carboxylic acids, CH3, C double bond O, then H. Why we make it like that? Because each carbon must take 4 bonds. So it will be C with 3 H's, with the other C, with O, with O, with H. Sharing by 1, sharing by 1, sharing by 1. After that, for the sharing carbon with oxygen, in this case, you will find that sharing by 2 for each one, sharing 2 with another 2. While in case of carbon with oxygen and hydrogen, sharing by 1 with 1, and with hydrogen with the other 1. The remaining for each oxygen, we have remaining 4. 1, 2, 3, 4. 1, 2, 3, 4. To be like that. For CH3 by 2S, it means that S is central atom with C with 3 H's, and the other side C with 3 H's. So central atom S, C, with the other three H's. 1, 2, 3. The other side, C, 1, 2, 3. Sharing each one by one. And then you will find that for sulfur group 6, there is 2 remaining 4. While for carbon 440 and H110. So remaining for S4 to be like that. After that, we have drawing of joint covalent. We have diamond, graphite, and silicon. For diamond and graphite, they are elements, and then silicon oxide is a compound. For diamond, you'll find that each carbon atom combined with 4 strong carbon atoms and tetrahedral shaped. While in case of graphite, each carbon combined with 6 carbon and hexagon shaped. In case of silicon, like diamond, each silicon combined with 4 oxygen and tetrahedral shaped. And then we are saying SiO2, not SiO4. Explain why? Because each silicon combined with 4 oxygen and each oxygen combined with 2 silicon. So it is SiO2, not SiO4. For joint covalent, different from simple covalent, that joint covalent, all of them solids, while in case of covalent, you may have solid, liquid, or a gas. Also, in case of joint covalent, have high melting and boiling, while in case of simple covalent, low melting and boiling. And in case of graphite, conduct electricity. For diamond, you'll find diamond hard and strong, can be used in cutting, drilling, and jewelries, while in case of graphite, you'll find it soft and conduct electricity. So soft, it can be used as lubricants and in pencils, while conduct electricity because it contains free moving electrons, so it's used as electrodes, inert electrodes, and electrolysis. Silicon oxides, we said that SiO2, not SiO4, because each silicon combined with 4 oxygen and each oxygen combined with 2 silicon. Okay, after that, for explanation of ionic, covalent, and metallic, you will find that in metallic consists of positive ions surrounded by sea of free moving electrons and layers slide over each other. After that, number 3, making salts. For making salts, we have 3 methods for making salts. Number 1, neutralization or excess method. Number 2, titration. Number 3, precipitation. For the first one, neutralization is formed between acid, this is aqueous, and base solids, This base, you'll find a transition metal, and it can be metal or metal oxide or metal hydroxide or metal carbonate. Like, for example, if we have copper oxide, the solid reacting with hydrochloric acid aqueous. These neutralizations is the first type, or excess method. Case number 2 is number A. Number B, in case of titration. Titration is formed between acid, it is aqueous, and alkali, also aqueous, non-transition, like group 1 and 2. Like for the reaction between NaOH, this aqueous, and HCl, this also aqueous. In case of precipitation, precipitation formed between two soluble salts. Mixing together to produce soluble salt and insoluble salt. In case of soluble salt, we'll make crystallization. In case of insoluble salt, we are washed with distilled water, then dry. Like the reaction between NaCl aqueous and AgNO3 aqueous. For the first method, neutralization. Or excess method. At the beginning, we have a beaker that contains acid. We are heating the acid to speed up the reaction. Then, with a spatula, having metal or metal oxide or metal hydroxide or metal carbonate. Then, stirring with glass rod. We are adding until excess. How can we know this excess? Solid appears down, or no more solid dissolves down. Then, this is number 1. Number 2, we are making filtration. Why we are making filtration? To remove the excess of metal oxide. Then, number 3, we are making crystallization. Heat, cool, filter, dry. So again, for neutralization, we are using neutralization if we have acid and base solid. This is here base solid. So are using neutralization. In this case, we have acid heating the acid first and then moving or transferring the metal oxide with spatula. We are adding by spatula and stirring with glass rod until excess more than enough to react. And then we'll make filtration to remove the excess. We are adding excess to make sure that all acid reacted. And then we are making filtration to remove this excess. And then crystallization. Heat, cool, filter, dry. Heat the solution till crystallization point. Allow to cool, then filter, and then dry. This for the first one. Like the reaction between copper oxide, for example, solid, and hydrochloric acid aqueous. Number B, for titration. In case of titration, you will find that we have burette, and then we are filling burette with acid till 0. And then known volume of alkali, like 25 centimeter cubed or like that. And then adding indicator, methyl orange or phenolphthalein. In case of methyl orange, you will find that the color will change from yellow to orange or red. Phenolphthalein from pink to colorless. We are using titration in case of acid, aqueous, and alkali aqueous. And then we are filling the burette with acid, then known volume of alkali, adding indicator, make titration until the color change, then repeat without indicator. This is number 1. Number 2, repeat the experiment without indicator. Why we are repeating without indicator? To obtain pure crystal. Why we are using indicator first? To indicate the ending point. Number 3 will make crystallization. This is like if we have the reaction between sodium hydroxide, this is aqueous, and hydrochloric acid, this is aqueous. For the third type,
دكتور
اتفضل.
دكتور احنا المفروض نقول لازم يبقى الفوليوم سيم ولا لا يعني إننا اصلا ما قلناش ان نستخدم the same volume مثلا of acid بعد يعني لما نعمل repeat للاكسبيرمنت لازم نعمل ان احنا نستخدم same volume of acid ولا لا.
Repeat the experiment with indicator. At the beginning, we made titration, okay? This at 0. Then the reading, for example, will be 10. And the other one, we have 25, for example. And then the reading till 10, the color change. So we are knowing that 10 will react with 25. So repeat without indicator with these values.
اوكي تمام يعني لازم نكتب same volume of
لا
acid
لا، ما اقول
عشان
repeat without
نستخدم
indicator.
ال10
ما هو خلاص انا كده عملت الاكسبيرمنت خلاص. اوكي، الاكسبيرمنت بتاعتي عملناها. لما عملت الاكسبيرمنت والناس استخدمت انديكيتور تو انديكيت ذا اندنج بوينت، يجيب لي الاندنج بوينت. ما هو دي معنى ان انا استخدمت انديكيتور. انا كنت معايا النون فوليوم اوف الكلي ومعيش فوليوم اوف اسيد ما اعرفش كام. Then after making indicator make titration until the color change. Until the color change say مثلا هنا كان 25 انا قلت نون فوليوم هنا. طيب until the color change يبقى الريدنج هنا say مثلا for example 10. Repeat without indicator خلاص انا هاخد بقى 25 وال 10.
اوكي.
So repeat without indicator and then crystallization. For the third type, for precipitation. In precipitation method, we must have two soluble salts mixing together to produce soluble salt and insoluble salt. This is like if we have the beaker mixture of the two salts and then adding water, then stirring. So again, in case of precipitation methods, we are taking the mixture in a beaker and then adding water, stirring. This is number one. Number two, filtration. Number three, if we need the residue, we are making wash, then dry. If we are need filtrate, crystallization. So again, we are mixing we have the mixture mixing together and then adding water, stirring, make filtration. After making filtration, if we need the residue, we will make wash and dry. If we need the filtrate, we will make crystallization. And then this like if we have NaCl aqueous plus AgNO3 aqueous, both of them two salts and they are soluble. They are mixing together to produce NaNO3 aqueous and AgCl solid, so produce aqueous, soluble, and insoluble salt. And then we said before the insoluble salts for chloride, silver, and lead, for sulfate, barium, calcium, and lead, carbonate all except sodium, potassium, ammonia. After that, for Haber pros and contact pros, for the difference between Haber and contact, Haber pros and contact pros. What's the difference between them both? For Haber pros is the preparation of ammonia N2 plus 3H2 gives 2NH3. And in case of contact pros, preparation of sulfur trioxide, 2SO2 plus O2 gives 2SO3. And then preparation of sulfuric acid. Both of them are reversible and exothermic. How can we obtain nitrogen fraction distillation? Of liquid air? Hydrogen from cracking of alkane, this is inorganic, or electrolysis of water. Sulfur trioxide, burning fossil fuels containing sulfur. For the conditions, for temperature, pressure, and catalyst. Temperature for both 450. Pressure 200 atmospheric pressure and 2 atmospheric pressure. For the catalyst, iron, vanadium pentoxide. And then after that, explain why. We are using low temperature, high pressure, add catalyst. The temperature not lower than 450. We need the reasons for each one. For the first one, low temperature because the reaction is exothermic. So by decreasing temperature, the reaction moves forward and more yield is produced. The reaction moves forward and more yields produced. In case of high pressure, the number, because the number of moles and reactant is greater than product, so by increasing pressure, the reaction moves to the last number of moles. So it moves forward and more yields produced. In case of catalyst, to speed up the reaction. Then the temperature not lower than 450 because the reaction will be too slow and cost small. So again, for the difference between Haber and contact, you will find that Haber process N2 plus 3H2 gives 2 NH3, contact process 2SO2 plus O2 gives 2SO3. And then how can we obtain nitrogen and hydrogen? Nitrogen from fraction distillation of liquid air, while hydrogen from cracking of alkane. In case of contact process, you will find that SO2 produced from burning fossil fuels. After that, for the conditions, temperature 450 for both, for pressure 200 in Haber and 2 in contact, for the catalyst iron and vanadium pentoxide. Why we are using low temperature and high pressure and adding catalysts? Exothermic means that delta H equal negative in both. Because in case of temperature, because the reaction is exothermic, So by decreasing temperature, the reaction moves forward and more yield is produced. For the pressure, by increasing pressure, the reaction moves to the less number of moles. We have 4 moles and 2 moles, and here we have 3 moles and 2 moles. So by increasing pressure, the reaction moves to the less number of moles, so it moves forward and more yield is produced. We are adding catalyst to speed up the reaction, and then we didn't decrease the temperature lower than 450 because the reaction will be too slow and costs more. After that, we have factors affecting rate and factors affecting equilibrium. Factors affecting rate and factors affecting equilibrium. For factors affecting rate, you'll find that we have temperature, pressure, concentration, catalyst, light, and surface area. For the light, photosynthesis process and photographic films. And then these factors directly. Rate, it means that speed, not amount. While equilibrium, amount, not speed. So for factors affecting rate, it means that affecting the speed of reaction, not the amount of the reaction. And then for temperature, how can we know this? For temperature increase rate, because particles gain energy. This in case of temperature. For pressure and concentration, particles gets closer. For the catalyst, decrease or lower activation energy. And then for these factors, you'll find that by increasing any factor, temperature, pressure, concentration, catalyst, light, or surface area, the reaction being faster. Colloid increases and particles moves faster, rate of reaction being faster. In case of temperature, we said particles gain energy, pressure and concentration, particles gets closer. In case of catalyst, lower activation energy. And then factors affecting equilibrium, we have concentration, and then the reaction in concentration moves from high concentration to low concentration. While in case of pressure, if you have number of moles, if number of moles are reacting greater than product, so will increase pressure to move forward. If the number of moles in product is greater than number of moles in reactant, you are decreasing pressure to move forward. If the number of moles in reactant equal number of moles in product, equilibrium, pressure doesn't affect. For temperature, It depends on if the reaction is endothermic, it means that delta H equal positive. We increasing temperature, it moves forward. While in case of exothermic, delta H equal negative, decreasing temperature and the reaction moves forward. After that, for the effect of heat, thermal decomposition for hydroxide, carbonate, then nitrate. In reactivity series, you will find that for potassium and sodium by a method, and all other metals with different method. So we have for potassium and sodium, and then from calcium till the end. In case of potassium and sodium, for the effective heat hydroxide and carbonate, no effect. And in case of nitrate, decompose partially to form metal nitrite plus oxygen. If you have, for example, potassium hydroxide, no reaction. Potassium carbonate, no reaction or no effect. In case of potassium nitrate, it will form potassium nitrite plus oxygen. In case of calcium till the end in the reactivity series, you will find that all of them will produce metal oxide. In case of hydroxide plus water, in case of carbonate plus carbon dioxide, in case of nitrate plus nitrogen dioxide and oxygen. Like for example, if we have calcium hydroxide, CaOH by 2 will produce CaO plus H2O. CO3, CaO plus CO2. CaNO3 by 2. CaO plus NO2 plus O2. So it will be like that. Ahmad, pause the recording. Extraction of metals. From their ores. We have extraction of iron and then making steel, then extraction of zinc and extraction of aluminum. For the first one, extraction of iron, we will find that carbon reacts with oxygen to form carbon dioxide. Then Carbon dioxide reacts with carbon to form carbon monoxide. Then iron trioxide reduced by carbon monoxide to form iron and carbon dioxide. After that, limestone is heated to form lime and carbon dioxide. Lime reacts with silicon dioxide to form slag. For the reactions, this exothermic equation, and then this redox reaction, thermal decomposition, and then neutralization. This is the name for each one. Exothermic reaction, and then redox reactions, thermal decomposition, and then neutralization because calcium oxide, metal oxide, which is basic, and silicon dioxide, non-metal oxide, which is acidic, reacting together to form slag, calcium silicate. This is for extraction of iron. After that, for making steel, by passing oxygen current on molten iron, we have here molten iron, and then oxygen current while passing through molten iron. By passing oxygen current on molten iron, you will find that sulfur, it changed to sulfur dioxide gas evolves, and carbon changed to carbon dioxide gas evolves, and silicon changed to silicon dioxide. Silicon dioxide reacts with calcium oxide to form slag. Slag is removed, carbon is added. Because steel consists of iron and carbon, and steel is harder than iron. So again, how are we making steel? By passing oxygen current. The impurities oxidized. So this is number one, passing oxygen current. Number two, these impurities oxidized, and sulfur changed to sulfur dioxide, carbon changed to carbon dioxide, silicon changed to silicon oxide, that reacts with calcium oxide to form slag. Number three, slag is removed, carbon is added. So three steps by passing oxygen current in molten iron. So impurities oxidized, sulfur changed to sulfur dioxide, and the carbon changed to carbon dioxide gas evolves, and silicon changed to silicon dioxide that react with calcium oxide to form slag. Slag is removed, carbon is added. After that, for making zinc or extraction of zinc, for each ore we have the name. For iron, hematite. There's iron trioxide. For zinc, zinc blende. This zinc sulfide. For aluminium, this bauxite. This aluminium oxide. For extraction of zinc, you will find that zinc sulfide reacting with oxygen to form zinc oxide and sulfur dioxide. Then zinc oxide reacting with carbon to form zinc and carbon monoxide. So you'll find that zinc is heated till vaporized, and after that zinc used in sacrificial protection. What is meant by sacrificial protection? You will find that zinc is more reactive than iron. Zinc oxidized, iron reduced, zinc corroded, and iron doesn't corrode. So again, for zinc, zinc blende or zinc sulfide reacting with oxygen to form zinc oxide and sulfur dioxide. Zinc oxide can be reduced by carbon to form zinc and carbon monoxide. And then zinc is heated till vaporized. Zinc can be used in sacrificial protection. For sacrificial protection, zinc is more reactive than iron. Zinc oxidized, iron reduced, zinc corroded, and iron doesn't corrode. For extraction of aluminium, aluminium oxide is called bauxite. Dissolve in molten chloride. Decrease the melting point of mixture. And then you'll find that aluminium is positive moves to negative, and oxygen negative moves to positive. Positive is anode, oxidation takes place, negative cathode, reduction takes place. And then for the half ionic equation, you'll find that 2O negative 2, losing 4 electrons to form O2. Then oxygen reacting with a container made up of carbon or graphite to form carbon dioxide gas evolves. After that, aluminium formed at cathode, Al3 positive, gaining electron to make reduction to form aluminium. Okay, Ahmed, stop recording.